All right, these are 8B notes. So this is multiplying and dividing rational expressions. So let's get started. So example 1, we're looking at all monomial numerators and denominators. So these are already in, technically they're all factored already. So your first goal here for 8B is to factor every numerator and denominator. Well, we don't have to do that because it's already done for us. I think one of the easy ways to look at this is you're just combining the fractions. So really, we're going to multiply, just think about multiplying fractions. You multiply across the numerator, and you multiply across the denominator. I'm not actually going to multiply it out. With monomials you certainly can, but you don't have to. I will reposition some of the monomials. The numerator I will not. I'm going to write all the coefficients or the numbers first, the factors that are numbers first. So I'm going to switch around the end of the fourth and the 10 by the commutative property of multiplication. You can do that. Now we're looking at 4, 2, and then 3 and 10. And looking at what can we simplify there? Well, you really have like a 4/10 that you can simplify, or you could simplify the 2/10. It does not matter which one you go with. But we need to simplify one of them. I'm just going to choose the 4/10. I'm going to divide the 4 by 2 and the 10 by 2. And now if we were to multiply straight across, so 2 times, so let's look at the 2 times 2, that's 4. And then in the denominator, we have 3 times 5, that's 15. Look at the fraction, 4/15. Can we reduce that at all? No. So let's move on. Now that's the coefficients are reduced. Now let's look at the variables, end of the first and end of the fourth. There's 1 n in the numerator, 4 in the denominator if multiplied. 1 would be simplified, and it will give you end of the third. Otherwise, typically you just subtract exponents, take your biggest exponent, subtract your smaller, and your answer will go where your bigger exponent was. So 4 minus 1 is 3. So this will become n to the third. And that one's gone. And here's your final answer. On number 2, we're no longer dealing with monomial numerators and denominators. So our first step is to factor. So we need to factor k squared plus k minus 12. Well, there's a shortcut when the a is 1, so this is a trinomial, 3 terms, it's a quadratic. Main thing is this is a quadratic. Whenever you have a quadratic and the a is 1, you can do what 2 numbers multiply to negative 12, so 2 numbers multiply to negative 12, and those same 2 numbers have to add to 1. So 2 numbers multiply to negative 12 that add up to 1, and you should get negative 3 and positive 4. So your shortcut is, instead of doing Punnett square, those are actually your second terms of each binomial. We have a negative 3 and a positive 4. To get k squared, you're going to need to do 2k, so k times k. Think about it, if you did k times k is k squared, so that's how you get the k squared. And there's your factor. So I'm going to write that first trinomial, rewrite it as in factored form. I'm going to look at the denominator next. K squared minus 5k, k squared minus 5k plus 4. Again, the a term is 1, so then it's what 2 numbers multiply to 4 that add up to negative 5, and that's negative 4 and negative 1. So our factors are minus 4, minus 1. To get k squared is k and k. And there are your factors. Now we need both, the first fraction is factored totally. Second fraction, the numerator. Again, the a term is 1. The a is 1 in that quadratic. So we're going to do what two numbers multiply to 9, positive 9, that add up to negative 10. And you should get negative 9 and negative 1. So your factors are k minus 9, k minus 1. And lastly, our denominator, k minus 9, is there a greatest common factor? I never even talked about that with any of the others, but there were no greatest common factors. You should always do that first. Is there a greatest common factor? No. It is a linear binomial, meaning it's to the exponent of 1 instead of a quadratic like what is exponent of 2. This is linear, so if there's no greatest common factor, that's just going to be it for the factor, just k minus 9. All right, now we're going to look at it. Really, all you're going to do is you're going to combine the fractions. So you're going to have numerators and denominators, and you're going to look, and I'm going to rewrite this actually. I don't like the way it looks. I'm going to combine it as one fraction. You don't have to do this step. Sometimes it helps with just distinguishing, so you're looking at as one big fraction. So multiply across the numerators, multiply across the denominators. All right, now you're looking, is there a k minus 3 in the denominator? No, so that's going to stay there. Is there a k plus 4 in the denominator? No. Binomials have to be identical. K minus 9 in the denominator? Yes. Those are going to get reduced, simplified. K minus 9 divided by k minus 9, that is 1. And lastly, is there a k minus 1 in the denominator? Sure is. That is going to get reduced to k minus 1, k minus 1 is going to be 1. Rewriting what we have here, we have the numerators k minus 3 times k plus 1 times 1 times 1. That is k minus 3 times k plus 4. In the denominator, we have a k minus 1 times 1 times 1. That's just k minus 4. And I know there's a urge to do something with these two, but k plus 4 and k minus 4 are not the same. Binomials, trinomials, they all have to be, the factors have to be identical if factored completely. All right, example 3. Here we have division. So it's a little bit different than multiplication. There is one step for this that's got to change, and you're going to change the division to multiplication. But you can't just change that. You have to do something else. And with fractions, you can flip the numerator and denominator of the second fraction, and it works out perfectly. So the k plus 8 over 3k plus 6 is going to stay the same, the first fraction. Change the division to a multiplication. Then we're going to flip the numerator and denominator. So this was the denominator of the second fraction. Now k squared plus 9k plus 14 is now your numerator, and 2k cubed plus 16k squared is now your denominator. And now we have a multiplication problem, which is awesome, so we know what to do. Now we're going to look at factoring the numerators. K plus 8 cannot be factored, so that's just k plus 8. The denominator, 3k plus 6. What's the greatest common factor there? It should be 3. And you divide each term by 3. K plus 2. So one of the factors is 3. The other factor is k plus 2. Multiplied. And if you want to combine it as one fraction, you certainly can. This numerator. The numerator is, the a is 1, so you do what two numbers multiplied to c, that add up to b. So what two numbers multiply to 14? So that's 7 and 2. So that's going to be k plus 7, k plus 2. Those 7 and 2 multiply to 14 and they add to 9. So there's your factors. And in the denominator, let's take a look at what we have here. We have a greatest common factor of 2k squared. And let's see, after we divide each term by 2k squared, we have k and plus 8. K plus 8 is a linear binomial. There's nothing else to do factoring wise. That's as small as you can break it down. All right. Now we're going to look at it. I'm going to rewrite this all as one fraction, k plus 8 from the first fraction, k plus 7 from the second. These are all your numerators and all the denominators. Look at what is in common. We have a k plus 8 divided by k plus 8. We have a k plus 2 divided by k plus 2. Really, there should be ones. K plus 8 divided by k plus 8 is 1. K plus 2 divided by k plus 2 is 1. And we do not have any monomials in the numerator, so there's nothing to simplify there. And I keep running out of room. In the numerator, it's 1 times k plus 7 times 1 is k plus 7. In the denominator, we have 3 times 2k squared is 6k squared. Monomials and binomials cannot be simplified unless there is a greatest common factor amongst every term, and there is not here, so that is it. That is your final answer. Hope this helps. Thanks.